All right, section 2.2 is on Venn diagrams and set operations. A Venn diagram is just a picture to display some information about sets. The Venn diagram is usually shown this way with a rectangular box, and we talk about the universal set first. The U, the universal set, is the set that contains all the elements being considered in a given discussion or problem. So in this case, we're talking about let U be the students in this class. So we label this as U. Within this set, we're going to have some students who have blonde hair. We have some students who have blue eyes. So we're going to show what can happen with these blondes and blue eyes. You know, in reality, you could have people who are blonde and blue-eyed. You could have some who are blonde but not blue-eyed. They could be not blonde but blue eyes, or none of the above. So we're going to show what all that relationship is. So this first one is, I want to show that there is no blonde that has blue eyes. So set A is our blonde, set B is our blue eyes. So if there's no blonde that have blue eyes, that means these two sets are totally disjoint. Disjoint means they don't touch each other. There's nothing in A that is in common to B. This is the Venn diagram for disjoint sets, and that is sets that have no elements in common. There will be no overlap in the picture. We may have the situation, the exact opposite of that. All students who have blue eyes also have blonde hair. So this is still labeled U for our universal set for this whole class. And we have set A, which is the big circle here, which is our blonde hair. And we have everybody who had blue eyes also has blonde hair. Everybody who had blue eyes is part of the bigger set of the blonde-haired students. This also shows that B is a proper subset. Obviously, it's a subset because B is inside circle A, but it is a proper subset because these two things are not equal. Sometimes we have exactly the same two sets. In other words, in this case, we have our students who are blonde are exactly the same students who are blue eyes, which means I would just draw one circle. I could pretend to draw two. Here's set A, which were our blondes, and set B, who are our blue eyes. It's the same set. Notice we could say that A is a subset of B. If you think about last section, we could say B is a subset of A, and we'd have to use this symbol. We cannot use the proper subset symbol because A equals B. All right, we're going to take Venn diagrams that are already drawn and see if we can answer these questions right here. Now, first off, you have to see this Roman numeral 1, Roman numeral 2, Roman numeral 3, and 4. Those are just labels of particular sections. Those are not individual elements. The elements are in the little letters. So first off, we want to determine what our U is. Well, our U is everything that's in this whole picture, which is A, B, C, D, E, F, and G. And it is a set, so we should have the braces around it. If we want to name what's in set B, we just look over here at set B, and what's there is D and E inside the braces. All right, part C is asking for the elements in A, but not in B. So this is all of my A, which is A, B, C, D, but D is also located within set B, so I cannot list D. So this is A, B, C. Part D asks for the set of elements in U that are not in B. So what's inside this whole rectangle that's not in B would be all of this and these two, but not in B. So this is A, B, C, F, G. And part E wants to know the set of elements in both A and B. What that means is what's in common to A and B. And the only element that's in common to both A and B is D. And remember, all of these are sets. They all should have the braces around them. The next Venn diagram is something called the complement of a set. The complement of a set, symbolized by A with this apostrophe, which we call not, A not, is the set of all elements in the universal set that are not in A. Here's our universal set. here is set A. Here's set A. So there's a bunch of stuff in set A, but what we're looking for is anything that's not in A. So we can color this in by shading everything outside here. All of this outside here is what's considered not A, because those are the elements that are not in set A. We can find the complement of a set without a Venn diagram by just looking at the universal set, looking at the set we're given, and finding everything that's in the universal set that's not in A. And the easy way to do that is just to mark things off. Set A has 1, 3, 4, 7, so I mark off 1, 3, 4, 7. And what remains is what is in the set of not A. So it is a set, we need the braces, and this is 2, 5, 6, 8, 9. Of course, you can put that in the order you want. I just put it in the order that appeared. The next Venn diagram is to show you the intersection of two sets, meaning we are going to have some students that have blonde hair and they also have blue eyes. Not everybody, just some with the blonde hair also have blue eyes. So we have two sets. We have our universal set. We have set A, which was the blonde students. We have set B, which is the blue-eyed. And some of the students have both. This shaded part right here is where A intersects B. This is set A intersects set B. That is, some of the blonde students also have blue eyes. We can find the intersection of two sets not related to Venn diagrams by just looking at these numbers here. I want to find A intersect B. The symbol for intersect is this upside down U. So A intersect B is look for any numbers that are in common to both of these sets. What's in common to both these sets is 10. This has 1, 3, 5, 7. This has 6, 8, 12. So the only thing that's overlapping between set A and set B is the element 10. And it is a set. Remember that the intersection of two sets is a set. Be sure you put the braces around it. Now to do B intersects C, same idea. I just look at these two sets. Is there anything that's in B that's also in C? And the answer is no. Therefore, B intersects C is the empty set. This was written in terms of A, B, and C, having a set name. You might not have a set name. It might just give you two separate sets. And I know these are sets because there are braces around them. Intersect. So what this is asking me for is, are there any elements in this set that's also in this set? And the answer is yes. The element 2 is in both of those. So the intersection of those two sets is the set that contains 2. Union is a little different. What union refers to is any elements that are members of set A or of set B or both. So union, set A, set B. And this looks like the same picture I drew for intersection, but the idea is what I would shade. That's what makes this different. Union is putting all this together. Think about unite. The symbol is a U, so think about unite and color this in. All of this is my A union B. Because what you have is you have the stuff that's in A, you have the stuff that's in B, and you have stuff that's in both. But it's all of this green stuff is my union. You can do the union for a Venn diagram. You can also do the union just looking at a bunch of sets. So if I want to do the union between these two sets, I just write them down. 7, 8, 9, 10, 11, and then go over to this set and write down anything we haven't already written. 6. The next element in this set is 8. I already have it. 10. I already have it. 12. And if you feel better, you could always just write that in order. You don't have to. Same idea here. 1, 3, 5, 7, 9. Union with 2, 4, 6, 8, which I just write those down because there's nothing that's being repeated. The last part is 1, 3, 5, 7, 9. Union with the empty set would just give me 1, 3, 5, 7, 9. The empty set in intersection and union, if you take a set A and you intersect it with the empty set, it's the empty set. Because what would be in common? Just the empty set. On the other hand, A union the empty set is A. So these are worth memorizing or writing down on your index card. An example right here, let's look at these two sets. I want to do A intersect the empty set. We'll take a look here at A. The empty set is just this. Is there anything in common between A and the empty set? And the answer is no, so it's the empty set. But if I want to do C union the empty set, so here's my empty set. If I unite these sets, I have Y, H, T, J, Z. We're going to do several problems where we're going to perform set operations. And when you perform set operations, you need to follow order of operations, which is telling us to do inside the parentheses first, just like you did for plain old arithmetic. So if you are asked to find, let's say, A union B not, because the A union B is inside the parentheses, first you find the union of A and B. That's the inside the parentheses. Then you find the complement. Remember, the apostrophe is complement. If you want to do A not intersect B not, you find that first, which is the complement of A. Then you find this, which is the complement of B. And then you do the intersection of those two sets. So here's our universal set, and here's set A and B. I would like to find A union B not. So I start by doing A union B. So A union B is 1, 3, 7, 8, 9, 10. Now that time I did it in order because that's just the way I think, but I could have easily written 1 through 7, 9. No reason to repeat 3, 7, and then 8, 10. So that's A union B. But I need the complement of that. So what I do, I just kind of put parentheses around here and put this. I don't know that that's real notation, but that's the way I think. So 1 through 7, 8, 9, 10 was my A union B, but I need the complement of that. So I go up to the universal set and I just cross off 1, 3, 7, 8, 9, 10, and what's left is just 2, 4, 5, 6. So my answer is 2, 4, 5, 6. The reason I do this with the parentheses and the not is just to save having to write down another step. All right, let's erase this and go back and do the next thing, which is A not intersect B not. I have to start by doing A not. So I look at A, 1, 3, 7, 9, cross them out of the universal set, 1, 3, 7, 9. So what I have is the set 2, 4, 5, 6, 8, 10. And I'm going to intersect that with, over here, let's erase this, I need B not. So B is 3, 7, 8, 10. Get rid of 3, 7, 8, 10. And what's left there is 1, 2, 4, 5, 6, 9. I need the intersection, and what intersection asks for is what's in common. What's in common is they both have a 2, they both have a 4, they both have a 5 and a 6, and that's it. So my intersection is 2, 4, 5, 6. A intersects C not, so I must start with A intersects C. So looking at these two, the intersection of A and C would be 1, 4, 8. So it's 1, 4, 8. I need the complement of 1, 4, 8, which means I need to cross out 1, 4, 8. And my solution then is what's remaining, 2, 3, 5, 6, 7. There's our solution.